Welcome to Minukuu tutorials. In today's tutorial, we're going to learn how to perform chi-square analysis in SPSS. So without wasting much time, let's import our dataset. I've already saved the dataset on the desktop and I will show you before importing it. So I have it in two forms, CSV and then Excel format. So to import it into SPSS, you first of all have to click on File. So you click on File and then you select Open. So when you click on Open, then you open the data set. So you simply scroll to Open Data. As soon as you click on Data, this dialog box displays. So in this dialog box, you have to trace the trajectory or the location of your file. We kept it on the desktop, so I'll click here. Sorry, my PC is in French, so bureau simply means desktop in French. So you click on desktop, then you scroll down. You realize that when I selected the file location, my file hasn't yet displayed. Why? Simply because by default SPSS recognizes SAV files. In other words, this save or whatsoever, I don't know what to call it, SAV files. Otherwise, SPSS statistics files. So in order to import our Excel file, we have to click here and then select Excel. As soon as I selected Excel, you realize that our dataset has displayed. So we now select it and hit Open. So when we hit Open, it depends. If you have already opened some worksheets, you will have to be careful here. If not, you open the existing the already opened worksheet instead of the new worksheet. So since I'm very aware, so I have to click here and select this one. This is the last one, this very one that I'm trying to import. And after that, I hit OK. So after hitting OK, you realize that SPSS has imported our data set, and we can now go ahead and perform our chi-square analysis. So let me dress it up. Okay, sorry. This data was actually collected to study the prevalence of falls in elderly age among adult population on a total sample of 160 participants. So what we are going to do today is to first of all look at it, what should I say, remind ourselves of the definition of chi-square analysis. By definition, chi-square analysis is a statistical procedure that is performed to assess the association, in other words, the relationship between two categorical variables, such as gender, which is a categorical variable, and then falls in elderly age, which is also another categorical variable. So we may be interested in knowing whether the prevalence of falls in males is greater than that in females in their elderly ages. In other words, do males fall a lot in their elderly ages compared to females? That's what the aim of this study. So based on our sample, we can calculate chi-square analysis to be able to determine whether falls in elderly age is related to gender. So to perform the chi-square analysis, you simply click on Analyze, and then you click on Descriptive Statistics. You move on and you click on cross tabs, as to construct the contingents table. So when you hit cross tabs, this dialog box displays. And then to first of all, okay, we'll construct the contingents table before explaining. So you simply send gender into rows. It doesn't matter, you could also put false into rows and then fall into columns. And after that, you click on cells and tell SPSS that you need both expected and observed counts or frequencies. When we talk of the observed counts, they are simply the what should I say, it's simply, what it means is this is based on a sample. The observed counts are what you've observed on this particular sample that we are studying. How many men experienced falls in their elderly ages, how many men did not experience, how many women experienced, how many women did not experience. However, in order to study whether gender is actually related to falls in their elderly ages, or in men and women in their elderly ages, it's important to know what should I say, the theoretical or the norms within the population, in case gender is not related to falls in elderly age. What are we expecting? For example, how many men are supposed to experience falls in their elderly ages? How many men are supposed not to experience? How many women are supposed to experience? How many women are not supposed to experience? So the differences between the observed counts and then the expected counts gives us what we term in French distance de chi-deux. In other words, it's a distance that we're going to measure, a difference, a statistical difference that we're going to measure between these observed and expected values. And with that difference, we're able to calculate the chi-square statistic and determine whether it's significant. There's a statistically significant difference in the prevalence of falls amongst elderly males compared to elderly females. So we hit expected and then we can hit continue. Now we click on statistics and then we will indicate that we are going to perform chi-square statistics. And after that, we have to also take notice of what we term as the effect size. Chi-square analysis, just like any other statistical test, do not really give us the it doesn't quantify the strength of the association. In other words, it can only allow us to know whether gender is related to, what do we call it, is related to falls in elderly age, whether there's a statistical significant differences or difference between the prevalence of falls in elderly female population and elderly male population. However, how strong is this difference? In other words, or how wide, how strong is this association? To know that, we have to calculate the effect size. So we have several effect sizes. We will select this one. Is it phi and Kramer's V effect size? And after that, we can hit continue. And after that, we can also, first of all, carry out some descriptive statistics, where we'll try to have a statistical summary of the whole data set in the form of a bar chart to study the prevalence of, just by observing, to know, it gives us an idea whether this could be statistically significant before we now look at the actual statistics. So we can hit display bar chart and hit OK to perform our chi-square statistics. So I guess it has already performed the chi-square statistics, and as you can see, there are several. One thing about SPSS is that it displays a lot of results, but we just have to go straight to what we need. So for instance, this is what case reporting summary, or the case processing summary. It's not really important to us. What is more important is the contingents table, in other words, the crosstab table. And here it is. You realize that all our, okay, first of all, you see that right now we have those two counts that I was talking about. We have the observed counts and then we have the expected counts. What's the principle of the chi-square statistics is that it will calculate the differences between the observed and then the expected counts of each, like between of each set. For instance, it will take how many theoretically, or let's say the expected count, let's say, of males that did not experience fall is what? 73 point, sorry, is 73.5, and then the observed counts is 86. So 86 minus 73.5. It will do the same for the observed here is 12, and then the expected is 24.5. So it will calculate these differences, and with these differences, what we term as this chi-squared distance, or what we term as a statistical difference or whatever, it will use this to calculate the chi-square statistic, and then it will give us the p-value to be able to determine whether the difference that we've observed between the males that have experienced the falls in their elderly age, which is 12, the females that have experienced the falls in their elderly age, which is 12, and then the number of males that have experienced falls in their elderly age, which is 28, whether this difference is statistically significant. We cannot tell. If we can also look at the histogram to give us an idea, but we still cannot tell until we perform the statistics. So here's the bar chart. I said the histogram. So here's our bar chart, and as we can see, the prevalence of falls in the female elderly population, in the male elderly population, which is green here, is greater than that in the female elderly population. But as to whether this difference is actually statistically significant, why? Because we cannot tell, because we have conducted our test on a sample, not the entire population. So we have to compare this to the theoretical, in other words, the population values. That's why it calculates the difference between the population values or counts, which is the theoretical, or the observed counts, the expected counts, and then that of the observed counts that we have in our continuous table, to be able to calculate the chi-square analysis and tell us whether this difference is statistically significant. But graphically, we can say, okay, there are more males that experienced falls in their elderly age than females, but we cannot tell whether this difference is statistically significant. To know this, we will have to go to our, we will have to look at our chi-square summary, or the chi-square test, which is here. And then, as you can see, one important thing to note is that SPSS always it always give you all the results, the possible results. However, you have to select what suits your, what should I say, what suits your, what do we call it, your methodology, let me put it that way. So you realize that, for instance, to test the relationship between two categorical variables, you can perform chi-square test, you can perform Fisher's exact test, you can perform chi-square test, that's Pearson chi-square test. You can also have this Pearson chi-square test. You can also perform Pearson chi-square test avec, sorry, I just spoke French, with yet continuity, or what we term as continuity correction. And then we can have the Fisher's exact test. So the question is, which one should we select? I will explain. Usually we look at the expected counts. When all the expected counts are when all the expected counts are greater than 5, as in this case, we can perform chi-square, what should I say, test of independence, in other words, Pearson chi-square. When at least one of the expected counts is less than or equal to 5, in that case we cannot perform chi-square, or we cannot perform chi-square test, but rather perform Fisher's exact test. But in our case, all of them are greater than 5, so we can select Pearson chi-square test. Now the question is, when do we select continuity, what should I say, chi-square test with yet continuity correction? We select that one when there is at least one of the expected values that is greater than 5 but less than 10. So, but in this case, all of them are greater than 5 and also greater than 10. So we simply stick to Pearson chi-square. And as you can see, this is the statistical test, the chi-square statistical value, which is here. And this is the degrees of freedom. It's a 2 by 2 table. So 2 minus 1, that gives us 1 degree of freedom. And then this is the p-value. Usually in SPSS, when the p-value is less than 0.001, it's represented as it is. So it's very, very significant. It's less than 0.05. So that tells us that there's a highly significant difference, or statistically significant difference, between the observed and then the, what do we call it? Between the observed values and then the theoretical values or the population values. In other words, there is a statistical, within the actual population, there is a statistically significant difference between the prevalence of elderly age falls in males and the prevalence of elderly age falls in females, as we have seen it graphically. So the, what do you call it, by the help of chi-square analysis, we've been able to conclude. So we'll be able to reject the null hypothesis, which says there is no statistically significant difference in the prevalence of falls or in elderly age, or elderly age falls in males and females, and rather accept the alternative hypothesis, which says there is a statistically significant difference in fall between elderly aged females and elderly aged males. Why? Because the p-value is less than 0.05. And this comes to the end of our chi-square test in SPSS. If you have any question, please do not hesitate to leave your comments in the comments box below, and I'm going to reply, if possible, with even a video to explain to the benefit of others. I thank you once again, and please remember to subscribe. If you like this video, let me know by clicking the like button. Subscribe please, and bye.